Okay. All right, so our focus again, it will be on angle measures. Now, one of the things that we went over yesterday was taking a look at an angle in standard position. So we kind of define that as an angle whose initial side lies along the positive x-axis and whose terminal side is kind of rotated about. So the positive angle measure goes counterclockwise. So we have an initial side and a terminal side. Then we mentioned yesterday revolution. So what's a complete revolution? So a complete revolution, so one revolution, is equal to 360 degrees or 2 pi. How about 3/4 of a revolution? Okay, so 3/4 of a revolution? Well, that would be 3/4 times 2 pi. So a full revolution is 2 pi. 3/4 of a revolution would be 3/4 times 2 pi, which would be 6 pi over 4 or 3 pi over 2 radians. What about half a revolution? Well, if a full revolution is 2 pi, that would be 1/2 times 2 pi, or just pi radians. So 1/2 of a revolution, pi radians. How about 1/4 of a revolution? So that would be 1/4 times 2 pi, which would be 2 pi over 4, which reduces to pi over 2. Okay, so these are angle measures in standard position. How about if we wanted to graph 5 pi over 4? Where does that angle lie? What quadrant is it in? Okay, so here's what I know. All right, so 1/4 of a revolution is pi over 2. 1/2 of a revolution is pi. 3/4 of a revolution is 3 pi over 2, and 1 full revolution is 2 pi. Now 5 pi over 4 is the same thing as 4 pi over 4 plus pi over 4. And 4 pi over 4 is just pi. This 4 over 4 is 1. So that's pi plus pi over 4. So it's going to be a half of a revolution, then plus pi over 4. So our angle measure, so here's our initial side here, and our terminal side is going to be here. So our angle measure, we go pi units and then plus a pi over 4. So this angle measure would be 5 pi over 4. So we're going to be dealing a lot with fractions in generating these standard angles. Okay. Let's take a look. All right. So splitting our circle up into fourths, splitting it up into sixths, and we're able to generate the key elements of our unit circle. Now, when you split it up into sixths, your angle measures are separated by 30 degrees. So we have 0 degrees, then we have 30 degrees. Plus another 30 degrees is 60 degrees. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210 degrees. 210 plus 30 is 240. 240 plus 30 is 270. 270 plus 30 is 300. And then 300 plus 30 is 330 degrees. All right, so graphing or drawing angles in standard form, the x-axis is your initial side, the positive x-axis, and then we go from there. Right. So these are angles in the positive direction. Go ahead and turn your sheet over. I think you have a second side to your sheet. Okay. So how about angles in the negative direction? So positive angles are clockwise or counterclockwise. Negative angles are going to be clockwise. Okay, so 0, 0. Actually, I'm sorry, 0, 0 there. Okay, so negative 30 degrees. And this would be negative pi over 6. Negative 45 degrees. Negative pi over 4. Negative 60 degrees. Negative pi over 3. Negative 90 degrees, which is negative pi over 2. So the only difference is the orientation. So we're starting here and we're drawing our angles clockwise. So if we were to take a look at negative 30 degrees, our angle would do this. It would start at the positive x-axis and it would be generated clockwise. Now, one of the things we're going to look at today are coterminal angles. Because this angle, where I have an initial side here and a terminal side here, if we took a look at this angle going this way, well, that's a totally different angle measure. So we know from the front side of this that this angle measure is 330 degrees. Right? So the orientation, though, is in the positive angle direction. So these two angles are considered coterminal because they have the same initial side, same terminal side, but they are different angle measures. One is a negative 30 degrees, one is a positive 330, but they share the same terminal side. All right, let's go ahead and finish this up. So this angle here would be negative 2 pi over 3 and negative 120 degrees, negative 135 degrees, negative 3 pi over 4, negative 150 degrees, negative 5 pi over 6, negative 180 degrees, and then this would be negative pi. Negative 210 degrees, negative 7 pi over 6, negative 200 and, is that 35 degrees or 25 degrees? Negative 5 pi over 4, what's this one? Negative what? 240? And how about this one? Negative 4 pi over 3. Okay, negative 270 degrees, negative 3 pi over 2. Okay, what's this one? So negative 300 degrees. How about in radian? Negative 5 pi over 3. Okay, negative 315 degrees. And negative, is it 7 pi over 4? Negative 330 degrees. And negative 11 pi over 6. And then finally negative 360 degrees. And then negative 2 pi. All right, so those are the angle measures that we typically use for our unit circle. So tomorrow we're actually going to go over these values. Okay, any questions on this? Your quiz today will be not necessarily on all of this, but it'll be if I gave you something like, negative 5 pi over 4, I might ask you what quadrant it's in. By the way, our quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I may ask you in standard position, what quadrant is this angle in? Yes. Any other questions? All right, let's go ahead and get the official definition of coterminal angles. Okay, coterminal angles. Two angles with the same initial side and terminal side and possibly different rotations. These are called terminal angles, coterminal angles. So two angles with the same initial and terminal sides and possibly different rotations are called coterminal angles. So they will share an initial side, they will share a terminal side. How many coterminal angles does an angle have? So 30 degrees, how many coterminal angles are there for 30 degrees?
2.
Every angle has infinitely many coterminal angles. Every angle has infinitely many coterminal angles because they're determined by the rotations. Theta is coterminal with theta plus or minus 360 degrees times k, or theta plus or minus 2 pi times k, where k is an integer. So k can be positive or negative. So basically, you find coterminal angles by adding or subtracting 360 degrees or 2 pi. Yes. Because there's not a limit on k. So, example, 420 degrees. 420 degrees. What's a positive and a negative coterminal angle to 420 degrees?
60 degrees.
Okay. So coterminal, I can go 420 degrees minus 360 degrees, and 420 minus 360 gives us 60 degrees. So 60 degrees and 420 degrees are coterminal. Now, how about if we go 60 degrees minus 360 degrees? That will take us to negative 300 degrees. Is that also coterminal with 420 degrees? Yeah. So now we have a positive and a negative. So if we think about it, 420 degrees, we're going to go all the way around 360 degrees. And then we're going to go 60 degrees more. So this is 420 degrees. Now, on the other hand, for a negative 300 degrees, we would start here. And I'd go negative 90, negative 180, negative 270. And then if I add 30 more, now I'm at negative 300. So 420 degrees is coterminal with negative 300. They both share the same initial side and terminal side. And also, if we just did 60 degrees, there's the angle measure there for 60 degrees. So all three of these angles are coterminal. And we can continue to add multiples of 360 to get different coterminal angles. So that's why every coterminal angle has an infinite number. All right, now here is the part where, not tricky, when we get coterminal angles in degrees, it's a little easier for us to add and subtract 360. But what if your coterminal angle is given to you in radians? Okay, I'd like a positive and a negative coterminal angle for 17 pi over 6. So here's the little trick I want you guys to use. All right, so this particular angle has been broken up into sixths. Its denominator is 6. I know that 2 pi is equal 12 pi over 6. I'm sorry, 2 pi, yeah, 12 pi over 6. Because 12 divided by 6 is 2. So instead of adding or subtracting 2 pi, we're going to add and subtract 12 pi over 6 because now we have common denominator. 12 over 6 is 2. So 17 pi over 6 minus 12 pi over 6 gives us 5 pi over 6. You guys are right. If I would have added, it would have been 29 pi over 6. But here I'm subtracting. So now I'm going to take 5 pi over 6 and I'm going to subtract another 12 pi over 6. And we get negative 7 pi over 6. So a positive and a negative angle that are coterminal with 17 pi over 6 is 5 pi over 6 on the positive side, 7 pi over 6 on the negative 7 pi over 6. The 29 pi over 6 that you guys mentioned, yes, that is coterminal as well. But oftentimes you may be asked to find a positive coterminal angle between 0 and 2 pi. So in this case, we would have to subtract. And I notice that 17 over 6 is greater than 12 over 6. So I already know that this is more than 360 degrees. All right, last part for today's lesson. And we're actually going to do these. Okay, the length of a circular arc. The length of a circular arc. S is equal to r theta. So S represents the arc length. R represents the radius. And the theta is our central angle. So the length of an arc is its radius times the central angle. Okay, so let's say we wanted the length of this arc here. And our radius is 2 centimeters. And our central angle is, let's say our central angle here is 240 degrees. Okay, how many degrees is 240 in radians? So 240 degrees times pi over 180 degrees. Degrees cancel. You can do that. So 24 over 18, what's the largest number that goes into both? 6. So 4 pi over 3. So our arc length, the length of the circular arc, would be our radius, 2 centimeters, times our central angle, which is 4 pi over 3. So it would be 8 pi over 3 centimeters. That would be the length of that circular arc. And if we wanted to figure out what that was approximately, we just multiply out the pi times the 8 divided by 3. All right, any questions